Today's DUI project done under the influence of magnetism. So we're going to be exploring magnetism a little bit and seeing how we can make a simple welding position holder. And these are what I think are fantabulous. They take the flux out of the ends of a north-south magnet. North-south, not on the side, the face. Not on the end, the face. So, kind of neat. Harbor Freight sells these north-south face magnets in a 2-pack for 99 cents. Go out and buy them. You too will enjoy these fantastic magnets. Now, you can just stick it on a block of steel. You get reasonable pulling power, not great, not bad. Around it with steel like this, we're taking the north side and the south side and forcing the flux to go to this end, and it ends up being a lot stronger. A lot stronger. Takes me 2 hands to get it apart. Doable, but that's just one magnet. A fully saturated magnet, because look, we see the locking to north and south. There's magnetic field left over outside a distance away from this. So we can see that, oh my goodness, there's stick-to-itiveness out on the faces. So this is saturated. If we go thicker and we're further from saturated, not as strongly saturated, let's just do another sandwich magnet. You can see the needle's not locking so quickly to the north and south face, but it still does. What kind of pull does this have? Not so great. Why is that? The area of this is huge, about half the size of this magnet. So the flux density in this becomes less because we have so much area in these thick sides. What we really want is something with a little bit more thickness, but not as much thickness as this. So let's go to just some welding tabs for gate latches and such. That pretty strong. It's stronger than the magnet I had originally, but its problem is you can slide it apart like that. This one stays put. Oh, I want to weld this nut or braze this nut to that. I can clamp my ground clamp to this and come in and zap, 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 or I can hit it with the torch and put a little braze on that and just get it to flow, and that's done. I have no other way of holding that easily. You can make positioning magnets. So in my video of how to make them, I do a multiple one where I fill up a whole bar, and to do that we want repelling faces facing down. So we put that repelling face down and this repelling face down. We'll just double check it there. Repelling face down. And then the next one, that's repelling. So we want that there. And then the next one. See, all those are repelling. Wants to come that way. So it's repelling. We need, the repelling is like faces, so we need this, since it's repelling these, we need this face facing the same direction. Then we put that there. Oh my goodness. Hold on a minute. Pretty stuck. I gotta get it aligned better. Arrgh! There we go. Watch it, watch it, watch it. Kill your fingers with this. Okay. Now this one, easily lift that. And it's just 4 magnets. A measly $2. And some scrap metal. Does just about as good as this one. Actually outperforms it. This is their $30 switchable magnet. And you say, how do you switch a magnet? And I say, well, if we took 2 magnets and we just want to look at what's happening with them, we'll put them so that they're additive. Then we can put them in the bar and we will see we get magnetic field, pagan, magnetic field on both of those. It's moderately better because there's 2 of them. So the flux in there is doubled. So it grips a little better. But if we wanted to like kill the field, we just turn them 90 degrees and then the north-south flux can't run. It's shorted to run through these to get to this, and there's virtually no sticking power to the, if you do the north-south, unless I knock the magnet all the way down, but there's virtually no stacks, fully unsaturated. See, no stickum. I'm hoping this style of magnet will be as useful to you as it is to me. I use it in welding all the time. My mom uses them as refrigerator magnets because she likes a strong refrigerator magnet that can hold up things. This is the magnet. It's essentially a piece of 1x1 tubing, 16 gauge, that's been sliced so that there's a little bit of a lip here, and it captures the magnet so it can't slide. And you just of doing one of these magnets with many north faces all facing this way and south faces all facing this way. They're placed inside this frame, and I have some wood dowels driven in to hold the plates and try to keep them from sliding. And if I actually used bolts, it would be better, but there we go. This is like 25 pounds, this block of steel. But this is a simple magnet you can make with different angle positions for welding. So you can hold in different positions. It gives about 10 pounds of holding capacity. And if you find yourself a piece of A36 with high magnetic permeability, it can give as many as 25 pounds of breakaway strength. A36 is the type of steel that we're using on this magnetic work holding positioner, or sandwich clamp, so to speak. It's not formulated with magnetism in mind, so it typically is sometimes great and sometimes poor. So it's not the first choice that you go to if you're designing for sellable magnets, because you just don't know what you're going to get when they're formulating A36. Sometimes the batch of recycled steel has things in it that make it great for magnetic permeability, and sometimes it's not there. They're only formulating A36 for certain strength and ductile properties. They don't really care about what else is in it from the recycled melt, as long as it's not influencing their ductile and strength properties. Most materials get their magnetism from the electron's spin, and it's not the spin of the electron around the atom, but the spin of the electron around itself, much like the day-night cycle. And that's what creates magnetism. When the metal electrons spin all line up in the same direction, you get magnetism. Magnetic fields can't be blocked. They're just, but they can be bent. So you can take the field that's coming out this way and move it to the edge, and that's what this is doing. And this works so great as a a magnet because we're diverting the field to the edges, and this edge, one edge will peg north, one edge will peg north, and one edge will peg south. Let's see, we'll see, you can see that's north and that's south. So this is north, yep, right, yeah, that's south, north. So south, north, that gives decent pull strength. So if it's unsaturated, if I put it like this so the fields aren't deep in this piece of metal, there is no stickability there. That saturated. It's showing some magnetic field leaking through the other side. So a large enough steel plate will block, well, it doesn't block, diverts a magnetic field around it. So, you know, you might be thinking, why do we have an air gap? Well, if we took away the air gap and we let these materials touch, we'd short out the magnet locally, and your field would not be as intense. It'd probably be less than the original magnet itself. But you can make these clamps so that they're really any shape on the other end, and hence you can have positioning clamps that are round or any such angle to hold something like that, and come along and hold something like that. Let's get that. So, and you know, come along and you can zap that at that angle repetitively if you need. There it is. Or, you know, you saw the other clamp, two-faced. You can make up a stronger clamp and use that. If you need a, please don't come out, it's coming out. That one I gotta glue. You can glue these in too with epoxy if you want. The steel makes a great welding clamp because it's got really poor heat conduction capability. So it protects the magnet from blowing apart. So you can get it red hot near this magnet. As long as these plates don't get red hot, your magnet will be safe. I've used them a lot, and I haven't broken a magnet in these. When I've forgotten my magnets and I've only had these around, if I weld up against these are gone the moment the metal gets hot. The last thing is the reason why I like this particular sandwich construction so much is that it's quite cleanable. If it picks up a lot of dirt, you just break it apart and get a rag and pull out the chips and pull the magnet out, wipe it with a rag and pull the chips off from this side, and you can put it back together all nice and clean and get back to work. So give it a try, make some welding positioners for yourself, and let me know what you think in the comments. Thank you very much. DUI Projects signing off.